These are your 3-2 notes. We are going to solve a system of inequalities. So we've already reviewed how to solve by graphing, substitution, elimination. Now we're going to solve inequalities. The only way you can solve a system of inequalities is to draw a picture of the solutions. You can't actually name all the solutions. There's too many to name. So you have to graph it. So you're going to draw a picture. Anytime we have inequalities, it involves shading. So we've already graphed one. We solved a regular inequality for an equation. Well, now we're going to take two inequalities, put them together, and basically you do the same thing twice. So you're going to graph the inequality, and then you're going to, the solid line or the broken line, you're going to shade. Then you'll graph the second inequality, solid or broken line, and then shade. And where the two shadings intersect, if there's an intersection of the shadings, that would be where there's solutions for both. Remember, when we shade, we're drawing a picture of the solutions of the inequality. So we're looking for the solutions that work for both equations, so that would be where the shadings overlap. If there is no overlap or no intersection of the shading, then there is no solution. Something we want to keep in mind when we do these, I want you to make sure that you remember to graph one, break one, shade one, repeat. Graph, break, shade, repeat. If you graph both lines, then decide to break the lines, then decide to shade, you'll get lost in all the different areas. So you want to completely go through one equation and then on to the next. So let's go ahead and try this. I would suggest having either highlighters, two different colored highlighters. Pink and blue work well, pink and yellow work well, and so do blue and pink. So, or if you have different colored pencils, that also works in this, or a pen and a pencil. So different colors, just to understand that the one color represents one inequality and the other one represents the other inequality. So if you want to grab those, good time to pause and get those supplies. So for this inequality, I have x greater than 5, and I'm actually going to graph that as x equals 5 to get my boundary line. So I know the inequality is there, but I'm going to graph the line x equals 5. That's a vertical line at 5. We just got to have to memorize that now or make a table of values. So there's my boundary. The inequality here tells me that those numbers don't work. So this is going to be broken because of that inequality. So I need to break that line. So I graphed the line, I broke the line, and now I'm going to shade that area. So remember, when we shade, we pick a point not on the graph like 0, 0. I'm going to check the point 0, 0. I'm going to plug it into the inequality. Is 0 greater than 5? 0 is not greater than 5, so that's false. And so I'm going to shade to the right where 0, 0 is not. And so I'm going to use my highlighter here. If you have a highlighter, since this is my blue equation, I'm going to use my blue highlighter, and I'm going to highlight everything to the right. Now my graph is a little bit off here, so I'm going to go off my page just to have more stuff to shade, more area. So try to make it as solid as possible. I know when we shade with a pencil, we don't really do the solid, but if you have the highlighter, if you're using the highlighter, it really helps to have it completely filled in. X plus y less than or equal to 3. I'm going to go ahead and use red for my pink highlighter. So I'm going to graph the line x plus y equals 3. In order to graph this line, I want to get into slope-intercept form. So I'm going to subtract x from both sides. Y is equal to negative 1x plus 3. And so my slope is a negative 1, and my y-intercept is a positive 3. So I'm going to go up 3 on the y-axis. That's going to be my starting point. And I'm going to work down 1, 1 to the right, all the way through that. And I'm going to continue on down. And so I'm going to connect and extend and shade after that. So here's my line. It is including those points. So because of this line right here, that equals 2 means that we're going to be solid. So I do not have to break this line. And then I'm going to pick a point not on that line. Again, I can use 0, 0 to check for shading. So when I plug in 0, 0, when I get 0, 0, I get 0 less than or equal to 3. Is 0 less than or equal to 3? That's true. So I'm going to shade where 0, 0 is. And I'm going to make sure I shade that entire region in the other highlighter color. So in this case, I'm going to use pink. And so everything where 0, 0 is, from this side down, all the way even into that blue area, on over. So for this particular problem, I want you to actually highlight that whole space. We're going to talk about each of these spaces, but and then afterward, I'll show you a nice little technique that you can use where we don't have to do all the shading. It's up to you, but it is a lot of excess shading. All of this pink area is really not my concern, but for this one problem, we will talk about it. We'll reference it. So once I get my shading all done, everything below the red line here, I actually have 4 different regions. I have a pink region, I have a light blue region, I have a dark blue region, which is my overlap. So that dark blue, or maybe if you have it at home, like that purple, that is your overlap. If you used a yellow and a blue highlighter, it would have bled to make green. If you used yellow and pink, it would have bled to give you orange. So wherever that overlap is, those are your solutions. You can't list your solutions. All you can do is just identify them. So this is the only area. These are the solutions to the system. So these are the ordered pairs, the solutions to both inequalities. The pink area are the solutions to x plus y less than or equal to 3. The light blue area are the solutions to the inequality x greater than 5. And the region that's not shaded at all, these don't work. These are not solutions. They don't work for the first inequality. They don't work for the second inequality. They don't work. If you plug those ordered pairs into either one, you'll get a false statement each time. So the pink worked for the second equation, the light blue worked for the first inequality, and then the dark blue or the overlap works for both. So in this particular case, since we're solving a system, the only part I'm really concerned about is this area right here. So if you're going to graph this way, you need to show me that you know that that's your solution. Either circle it, draw an arrow to it. Because graphing all of them, I want to make sure you understand which ones are solutions. I'm going to show you a different technique where you don't have to do all that wasted shading, because that took a long time to shade all that pink-purple color, and it really wasn't necessary for that little triangle. So for the second problem, we're going to shade, but we're going to use a different technique. We actually have 4 different inequalities going on here at the same time. And this is sort of leading us into the next section of our notes. So we're going to have more than just 2 inequalities that we're dealing with, or, so in this case, even though it looks like we have 3, we technically have 4, because that middle inequality is a combination inequality. So I don't care how many crayons and colored pencils and markers you get, the more colors you add, it's just going to get a disaster. So we have a different technique to use here. So I want you to use this technique on this section. So I'm just going to use colors to help me identify. So my first inequality, y less than 3, I'm going to underline it in red, and I'm going to graph the line y equals 3. That's a related equation. That's a horizontal line at 3. So I'm going to graph the line. Then I'm going to break the line because it says less than. And then I got to determine shading. So when I use 0, 0 as my point, when I plug in 0 is 0 less than 3. That's a true statement, so I need to shade below. Now this is where it's different. Rather than taking your highlighter, just take your pencil or pen that you're using and simply put little dots below the line. And this signifies that I'm shading below this line, not above. That's my symbol that my solutions are below. Okay? Let's go ahead and do the second part. So the second part I'm going to graph is this inequality right here, x less than 5. So x less than 5 is the second half of that between inequality. X less than 5 is really the equation x equals 5. And so x equals 5 is a vertical line at 5, going through x is 5. It's going to also be broken. And when I plug in 0, 0 into the inequality, is 0 less than 5? That is true. So I'm going to shade to the left of the green line. Now, the region above the red is not going to work because we're looking for the overlap of shading. So I only have to worry about putting little dots to the left of the green line all the way up to the red line. So now what we can see is that our solutions are where the red and green lines overlap. Okay, now we haven't shaded anything yet, but I don't have to dot above the red line because there's no solutions up there for red, so I'm not worried about the solutions in green. They wouldn't overlap. The next part I'm going to do is the first part of that combo. So if you look at this inequality right here, 0 less than x, if I wanted to, I could actually rewrite that as x greater than 0. I think that's a little bit easier to see if you write it the other way. So it's still pointing at 0 when I flipped it. That's a vertical line at 0. You can make a table of values if you're still struggling with vertical and horizontal lines. So here's my graph of that equation or inequality. It's going to be broken because it does not equal it. And I can't pick 0, 0, but I can pick 1, 1. So if I use this order pair 1, 1, 1 greater than 0, that's true. So I'm going to shade to the right where 1, 1 would be. So I'm going to shade to the right of blue, but I'm going to stay underneath the red line. So right now, what we have is this little rectangle where the red, the green, and the blue dots are all overlapping. We have one more to do, and that's going to be this x less than negative y. Well, I'm not a big fan of that, so I'm going to change it into an equation. X equals negative y. We're getting better. Whenever we graph, we want to have things in terms of a positive y, so I'm going to divide by negative 1 to make that a positive y value. Negative x equals positive y. I'm not a big fan of that. I'd like to flip it so that my y equals negative x. And I can put a plus 0 if you'd like to reference the y-intercept. So we did some changing of that equation, maybe just changing the sides, changing my y from a negative to a positive. So I'm going to start at 0, 0, and then it has a negative 1 slope. So I'm going to go down 1, 1 to the right, down 1, 1 to the right, all the way through till I hit that green line, because that's kind of the important line here. I'm going to connect and extend. Okay, we're going to break that one because it's still not equal to. So all of my lines in this particular problem were broken. And now I got to decide if I'm going to shade above that line or below that line. I can't use 0, 0 to check because it goes through 0, 0. So I'm going to use 1, 1 again. So I got to go back up to the original inequality and check 1, 1. So is 1 less than negative 1? And that's a false statement. So where 1, 1 is, a lot of people want to say, oh, it's in that interior triangle. It's actually not in the interior triangle. We got to shade below the purple line. So we're going to shade below the purple, but we're going to stay between blue and green. So I really don't have to worry about below the purple on the other side of the blue line or on the other side of the green line. And actually, the red line is kind of just null and void now. It wasn't even really useful here. So where do all of my lines come together? Well, the red line is below. We just can't see it. So the red line does include those values below. But where all of the dots overlap would be in this region right here. Don't forget the green line. So it's like a trapezoid area. I want to make sure you understand that it's not a triangle. It's between the green and the blue lines under the purple line, and red is part of that as well, because red is below. So that's how the book will show the answers. That's how I'll give it to you in the key. I won't show all the other shading. I will only show you the overlap. Okay? So there's that problem. One of the issues we have is parallel lines. When we graphed and solved a system of equations, we knew that parallel lines was going to give us no solution. But in this particular case, I've got 3 scenarios to show you. Let's just throw down 3 sets of parallel lines. And there's times where it will be no solution, but there's going to be times where there is a solution. So the first case is what if, let's go ahead and use some colors. On that first line, we would shade below it, but then on the second line, we're shading above it. If you were to picture that shading going on forever and ever in each direction, our solutions would actually end up in between. So even though the lines are parallel, the system of inequalities does share some overlapping ordered pairs. Okay, another scenario is what if we are above the first line and below the second line? If the shading continued in those directions, there would never be any overlap. So in this particular case, no solution would be the appropriate answer. There's not going to be any overlap. We would have shading to the left, shading to the right, but nothing overlapping. And then the third scenario could actually be 2 more scenarios. It just depends on how you look at it. If I shaded below each line, so if I shaded below the first line and below the second line, the overlap would actually occur underneath the second line. So there would be overlap over here. And I could show you a 4th one, but it's basically the opposite of this. If they both were shaded above, it would just be on the outside of the first line. So just because you get parallel lines, I don't want you to think that it's no solution. You've got to interpret this shading and where, if their shading is crossing or not. Okay? So, lesson summary. I gave you a freebie, I believe, somewhere. And for the practice problem, I just need you to do this quick system. Okay? It's really going to test your knowledge of horizontal and vertical lines. So take your time, make sure you know how to do it. If you don't know how to do vertical and horizontal lines, make a table of values. Make a table of values for the first one where your y values are 4, and make a table of the second one where your x values are -2 each time. Good luck.